Hi, welcome to part 2. So let's continue on. Now we're going to be looking at some triggerlicious functions here. And if you look at number 9, and we're talking about tangent lines. Tangent line. So let's go ahead and get rocking with it, right? So question number 7 says find this derivative. Now if you notice, the first one, this is just a simple power rule. But over here, we have our triggerlicious function, okay? There's our triggerlicious function. It should be a T right there. Alright, so when we're taking the derivative, the first one is going to be easy. Now don't forget, identify this as a derivative, h prime of x. You need the prime, right? Now, over here, if my rule said I'm going to drop my power, we already know what this is going to become, 12x. You don't have to put the first if you don't want to, plus, but when doing the 5, when doing the cosine, leave the 5 alone. Really just take the derivative of cosine, and you might recall that from before we said that this is negative sine of x. So therefore I'm going to write out my whole derivative, h prime of x equals 12x minus 5 sine of x. Now this homework is not this assignment, it's not very hard to do. Alright, number 8, okay, this is a tricky one, people hate these. Let's take a look at number 8. When you look for the derivative, I'm only looking for with respect to x. Be careful. This is something people don't know. Pi and even the number e are constants. Matter of fact, we basically treat anything that is not an x a constant. Even if I put down plus y, we treat that y like it's a constant. The only variable we're interested in for is that x. So when I'm taking the derivative with respect to x, I only pay attention to all the parts that have an x on it. So for the first one, I'm going to leave the pi alone. And then take the derivative of sine, well, that's just cosine of x minus, even though this is 3 pi squared, you're going to be tempted, bringing down the 2, making sure that is 6, but it's not. Remember, we're only interested in the letter x. I don't care about the pi. So we're going to leave that as 3 pi squared times, and then the derivative of cosine, negative sine of x. Same thing with e. You're going to be wanted. And I'm going to write that 3e squared. But remember, this is a constant. In other words, its slope is 0. So that's what it's going to become, minus 0 right here. And then I can write this out. Whoops, I used f. I just misspelled the letter j. That's okay. J prime of x equals pi cosine of x. I'm going to bring out the negative. Plus 3 pi squared sine of x. And that would be our answer. And notice above here I put down f prime, but the AP is okay. If you put f prime instead of j, they'll be like, oh look, they can't spell the letter j, and they're going to be okay with that. Mistakes, simple mistakes like that happen. Don't stress about those. Just really be careful. What we're really trying to take a look here is we're only looking at the letter x. All right, number 9, one of our favorite ones forever. Okay, how to write the equation of a tangent line. Okay, so let's remember the two things we need. One, we need a point. And they're going to give it to us. Well, look, that's nice. 1, negative 5. 2, we need the slope. Remember, the slope comes from the derivative. So we need the derivative of our graph. Well, looking at our power function, if I drop down the 3, this becomes 6x squared. What happened to the 7? It became 0, so I'm not interested in it. I want the slope at this point, but remember, I'm only interested in the x coordinate. X is 1. That's all I'm interested in. So the slope is f prime of 1. The slope at 1 is 6 times 1 squared. Now, how much work do you have to show? The more the merrier. The AP really likes to see understanding. You know the slope is the value of the derivative at 1. And then you can write your line. Remember, we are going to write this y minus y1 equals m x minus x1. And that becomes y, be careful, plus 5. Equals 6 times x minus 1. And there's our equation. Our last one? No, no, gotta be careful. Dangerous mathematics. Do not do the following. Okay, this happens every year. Somebody goes, that's y plus 5 equals 6x squared, x minus 1. Now, I guarantee you, some of you guys are not paying attention right now. You're going to do this. This is a no-no in math. There is no credit for this. None. Whatsoever. This is the derivative, not the slope. The slope, listen to me carefully, write this down, is is, a, number. If you get a variable there, you done messed up a run. Go back and fix it, okay? You need to have this as a number. Plug your 1 in. All right, now the last one is this next one here, number 10, is kind of a neat one. It talked about horizontal tangents. So we think, well, what can you tell me about a horizontal tangent? That's pretty easy. A horizontal tangent is where the slope of a function is 0. We know that. For example, like a parabola. Where is my horizontal tangent? Right up here, right? Where the slope is 0. So what we need is the derivative. That's the first thing we're going to need. So the first thing we need is f prime of x. And I can get that pretty easily. F prime of x equals, now we're going to do the rule. Drop your power. We get 3x squared plus 8x. Again, what happens to the 7? It goes to 0. Very good. Just goes to 0. Next, we're going to find the derivative, f, where the derivative is 0. Now, you might recall, we call this a special number. It's called a critical number. Okay? It's just where the slope could be changing signs. We're going to be using this a lot next unit, okay? So we get used to this. So by setting the derivative equal to 0, we find where slope is 0, which were the horizontal tangents. So I just take my derivative, 3x squared plus 8x equals 0. Be careful, factor out an x. Use your algebra skills. Equals 0, x equals 0, and negative 8/3. So we have two places where the horizontal tangents occur. These are where the horizontal tangents occur. In other words, you can think of these as vertices of a parabola. Now notice this is a cubic graph. And we all know what cubic graphs look like, right? This graph probably looks something like this. Of course, not drawn to scale. I mean, ours is probably more like that, because remember, one is at 0, the other one's at negative 8/3. So again, not drawn to scale, but we can kind of get the basic idea of what our graph looks like. We can start seeing the shape of our graph without a calculator. All right, the next one. Now, another thing we might ask for the AP might ask, or me, AP or quiz or test, is, find the points where they occur. In those cases, you need your y values. Think about how you would have to get those. All right, number 11, good application. Find k so that f of x is tangent to y. This is a big one. Make sure you get this one down. Okay, so if I were to graph this, a function f of x, we want to find a k so that the function is tangent to y. So here we're talking about the function tangent to y. So here's the function, here's our tangent, here's y. So here's f of x. Now f of x is curvilicious. This is not drawn to scale. Okay? And somewhere touching that, we have our graph of y. There's y equals negative 6x plus 1. Again, not drawn to scale, but the idea is kind of here. So what we're looking for is, of course, where they must occur. So two things must happen for being a tangent, okay? So at x equals c, and I want you guys to write this down. This is a big one. This is a big thing for tangency. This is what tangent at x equals c means. Two things have to occur at a point of tangent. The first thing you notice, if you notice, what's the first thing? At the point of tangency, they must have the same value. 2, well, they must have the same slope. These must be equal at that point of tangency. So I can use that. Well, if they have the same value at that point, I know I can set f of x equal to y. So I can say that k minus x squared equals negative 6x plus 1. Well, this really doesn't help me solve anything right there. But I also notice that they have to have the same slope. And in the same slope, we are talking that their derivatives are equal. They have the same derivatives. And that is what we're going to use also. So that tells me that f prime of x has to equal y prime. So I can do that. Now k is a constant, right? K is a constant, so it's 0. So we can write that down here, just remind us that k is constant. It's just a constant value, like 3. So I know that my derivative, f prime of x, is just going to become negative 2x. I just dropped my power. But what would be the derivative of y prime? What's the derivative of negative 6x? That's just negative 6. X is just 3. So once I have x is 3, I can now plug it into my value because that has x and k's. So now I'm going to find k. I can just plug it in. K minus 3 squared equals to negative 6 times 3 plus 1. So I can go k minus 9 equals, that's what, negative 17? So therefore k is negative 8. This is a very big topic for us. And the AP, and you will see this on the AP, you'll see the same concept on the quiz and your next test. Okay? Alright, so hope you guys enjoyed the videos. I can't wait to see you again. Bye-bye.